right, guys, I hope that you're having a good day. Today we're just going to look at a couple different problems just to review a couple different things that you're going to work on today. So let's take a look at this first word problem. I would also, before I start, I would like for you to have out your math notebook and a pencil so that you can go through these with me and work them out with me in your notebooks. That's what I'm expecting you to do, so that you have these examples in there. You do not have to copy the problems, but you do need to copy the work that we do. Okay, a recipe for a pan of brownies requires 1 50/100 cups of milk, 675 thousandths cups of sugar, and 1 500 cups of oil. How many cups of ingredients will there be in the mixing bowl? So as we've talked about, we're going to read each sentence and pick out what we know and what's important. So we know that in a recipe, so that would be 1, we need this much milk, this much sugar, and this much oil. So I can even label, if this is my milk, I need this much milk. This is my sugar, I need this much sugar. And if this is my oil, I need this much oil. Okay, so that's exactly what I know. This is what I need for my recipe of brownies. All right, let's keep going. How many cups of ingredients will there be in the mixing bowl? Well, these are my ingredients, so since I want to know how many cups, I would add. Okay, so remember our rule when we add and we have decimals. We want to make sure that our decimals are lined up. So I'm going to start with the 1 50/100. I'm going to mark it off because I used it. And then I'm going to use the 675 thousandths here. So I'm going to line my decimal up and then fill in the rest of my number. Did that one. And then 1 500. So I'm going to include my decimal. The 1 goes before it and the 500ths afterwards. So as you can see, we're not all completely lined up. So I'm just going to add zeros here to fill those spots so that all of my decimals go to the same place. Okay, now I'm going to add. So I'm going to bring my decimal straight down. 5 plus 0 plus 0 is 5. 5 and 7, that makes 10, 11, 12. 6 and 1 makes 7, and 7 and 5 again, 7, 8, 9, 10, 11, 12. Carry the 1, 1, 2, and 3. So my final answer is 3 225 thousandths of a cup. Let's look at another example. My friend walked in the clothing store with a $100 bill. So if this is my friend, again we're reading sentence by sentence, she has a $100 bill. She bought a coat for $45.63. So if this is my coat that she bought for $45.63, and she bought a shirt. So if this is her shirt, she bought a shirt for $22.89. Okay, so just from these two sentences, I know she went in with this much money, and these are the two things that she bought. So let's keep reading. How much money did my friend leave the store with? Notice it doesn't ask us how much she spent, it asks us how much she left the store with. Well, she went in with 100 and she bought something, so we have to figure out how much she came out with. So first we need to figure out how much did she spend. So we're going to add up her coat and her shirt. So this is what we just practiced doing. So 45 63/100, or $45.63, plus we're going to line up our decimal, 22.89. Bring our decimal straight down. 9 plus 3 is 12. 6 and 1 is 7. 7 plus 8 is 15. Carry the 1. 5, 6, 7, 8. 4 plus 2 is 6. So this is how much she spent at the store. If we go back up here, it asks us how much money did my friend leave the store with. So now we have to take our $100 and subtract it from how much she spent. But if you'll notice, this 100 doesn't have a decimal in it. But we can make it, since it's money, by just adding our 2 zeros here with our decimal. Now it makes it easier to line our decimals up with our money and subtract. So 0 take away 2. Can't do it. Well, I can't borrow from here. I can't borrow from here. I can't borrow from here, but I can borrow all the way over here in the hundreds place. So that becomes a 0. And then all of these become 9, so that this very last 0 can now become a 10. So 10, oh, let me bring my decimal down. Decimals always lined up. 10 minus 2 is 8. 9 minus 5 is 4. 9 minus 8 is 1. 9 minus 6 is 3. So how much money did my friend leave the store with? Our answer is $31.48. So when we are adding or subtracting decimals, it is important that we make sure that our decimals are lined up and that all of our place values are the same. Problem. A 2-inch binder costs $1.99. All right, so in my first sentence, I'm going to draw what I know. So a binder cost $1.99. Okay, this is for one binder. Again, we're reading it sentence by sentence, pulling out what we know. If my teacher buys a binder for each of her students, so each of her students are going to get a binder, and there are 21 students in the class. So I know that one binder is $1.99. So I could draw 21 binders. That would take me a while, but I could keep drawing 21 binders to represent the 21 students, and they each would cost $1.99. Okay, so my question is, how much money will my teacher spend on binders? Well, we could keep adding $1.99 21 times, but that may take us a while. So instead of doing repeated addition, we can simply just multiply $1.99 times 21. So you'll notice that we have a decimal here. So our rule when we divide a decimal is simply to just ignore the decimal and multiply just as if the number's not there. So you can see that I rewrote this problem with no decimal. We'll come back to the decimal in a minute, but let's solve the math. 1 times 9 is 9. 1 times 9 is 9. 1 times 1 is 1. So we're finished here, so we put a smiley face to hold the place. I'm sorry, running out of room you can't see. All right, then we're going to do 2 times 9, which is 18. So carry the 1. 2 times 9 again is 18, plus 1 makes 19. And 2 times 1 is 2, plus 1 makes 3. We add it up, and we get 9. 9 plus 8 is 17. 9, 10, 11. And 4. So here's our answer. But as I said, we're going to come back to this problem and we're going to count how many numbers are behind the decimal. So when I look at my original problem, I have 1, 2 numbers behind the decimal. There's no numbers here behind the decimal because 21 is a whole number. So since I have 2 numbers behind the decimal, I'm going to go to my answer, start at the end, and I'm going to move the decimal 1, 2 places and insert it right there. So since I had 2 numbers behind the decimal, I moved my place value 2 times. So then my final answer that the teacher would spend on all 21 binders would be $41.79. So our rule when we multiply decimals is to forget the decimal, multiply regular. Once you get your answer, go back and count how many numbers are behind the decimal in the original number. And that's how many times you move your decimal in your answer. One more example together. My class needs a piece of rope that is 2 8/10 meters long for a science project. So again, using our strategies of reading sentence by sentence, I know that my class needs a rope that is 2 8/10 meters long. Okay, that's what we need. Our teacher is going to cut the rope into pieces that are 2/10 meters long. So for the teacher, she's going to count 2/10 and cut it. Count 2/10 and cut it. Count 2/10 and cut it. And give them to groups. So the question is, how many groups are there? So since we are cutting our piece of rope into equal pieces that are 2/10, then our operation would be to divide. So if we think about, since we're dividing, We make our fraction, and we always ask, what is being shared? In this problem, we are sharing 2 8/10 of a meter long rope, and we are dividing and cutting it into 2/10. Okay, so since we are dealing with decimals, we can divide this in our regular standard division. Okay, so whatever goes on top, your numerator, that is what goes inside as your dividend. So 2 8/10 goes in here, and 2 8/10 goes here, and 2/10 is our divisor. Now, here's our rules for dividing a decimal. We have to make sure that our divisor is a whole number. Okay? If it's not a whole number, we have to make it that way. So in this case, this is not a whole number. So all we're going to do is move our decimal one time, and we now have a whole number. The rule is if you move the decimal here, you move it that many times on the inside. So then I moved it once, so I'm going to move my decimal once here. So now I'm going to rewrite my problem. I have 2 wholes divided into 28, and my decimal's here. Now our rule says if this is a whole number, then you bring your decimal straight up. We bring our decimal straight up, and we divide just like normal. 2 goes into 2 one time. 1 times 2 is 2. Subtract, get 0. Bring down our 8. 2 goes into 8 4 times. 4 times 2 is 8. We get 0. There's nothing left to bring down. And so since our decimal is after 14, that means that 14 is a whole number. There is no decimal needed afterwards. So even if you added zeros here, it wouldn't change that this is just 14. So when we go back to our problem, how many groups are there? There are 14 groups. So our rule of division is important. We want to make sure our divisor is a whole number. If it's not a whole number, we move our decimal. How many times we move it in the divisor? We move it in the dividend as well. We rewrite the problem. If it's a whole number, then we're good to go. We just bring our decimal straight up, and we can divide.